system and also with number system. Okay, so we are going to see calculus with parametric Course8. So first of all, let us see what are tangents, okay? So let us suppose that we have, I'm going to have a slideshow. Okay, and I'm going to have the laser, there's a laser. Just a moment, I'm arranging my slides. It's a laser somewhere. Ah, here, okay. So, yes, I took my laser now. Okay, so here, there is, suppose that there are two functions, okay? F and G. And these functions are written in terms of x, okay? Let us suppose that function f is written in terms of x and function g is written in terms of x. So let us say these are two differentiable functions, okay? And we want to find the tangent line, okay, at a point on a curve where y is also differential function. So the important thing here is that all these functions and y are differentiable function of x. And remember the chain rule. This was also mentioned in calculus 1. This is the chain rule. Okay. Here, derivative of y in terms of t equals to derivative of y in terms of x. We take derivative of y in terms of x. Then we take derivative of x in terms of t. So you can have, you can think it like that you can consider, in fact it's not like this, just with the logic, with the idea in your mind, that you can memorize it. Okay, you see that dy dt, it is dy dt, okay, these are same. Yes, so here, this is, you can write the same thing like this, okay? So here, this is dy dt, okay, dy, differentiation of y, derivative of y in terms of t, and this is here, derivative of y according to x, okay? So here, derivative of y over dx, let me take the max type to write it. Okay, I'm going to use another program to explain it here. In a minute it will open. Okay, here. Okay, so it's my trial. Okay, so yes, dy over dx. Okay, so it's equal to. So what we say here, let us here. Okay, it says it like this. You see this line here, the middle line. Okay, this is dy over dt. So we can write it dy over dt multiply by dt over dx. What we do, we reverse the second one. Okay, here when we turn this division, okay, we have two parts here. So let us say that we have two parts. Okay, we have two parts here. This is dy over dt and this is dx over dt. Okay, so when you multiply it, you reverse it. So that's what I am going to do. Dy over dt. Okay, dy. So let me take this one here. Okay, dy over dt. Okay, multiply by, what was it? Dt over dx. Okay, so this is dt over dx. Okay, or we can say it, we can say this is same thing as what was written there. Let me take this here. This is dy over dx. Okay, it was written here equals to, there's a this line, and here we have this here. Okay, this is dy over I write it. I have to have some more spaces here. Yes, okay. So equal to so I am trying to write that equation here. That's what I am doing. Okay, so dy over dx, okay, equals to here. This one is no, it takes the outwards. So okay, I'm going to write it here. Try it like that. So this is dy over dx equals to this one and one more of this one. Okay, that's better like this, dy over dt, and here it is dx. I need one more of this. This is dx over dt. Yes. Okay, so look here what I have here. So this is the first part. Okay, this is what is written in our presentation. You can see here, okay, this division. You know that here this is the denominator. The first one is the numerator, this first one is the numerator, and the second one is the denominator. So here what we do, we reverse this. We take dt up and dx as denominator. Okay, we turn it. So if we want to have it as multiplication, we turn. This is division, you know. And so here this is, okay, this is what is written there. So when we turn it, we get this part here. Okay, so when we turn it, we get this part here. So I'm showing that this, it goes to this part. So this, when we turn it, look here, this is dy over dt, this is dy over dt, and this is dt over dx. Okay, so let us continue. Yeah. Okay, so this is what we do, but here for it to be defined, what needed? We need that this denominator here shouldn't be 0. Okay, so if it is 0, it becomes not definite. It becomes undefined, and it is infinity, as you know. Before we were saying that it equals to infinity. So here the denominator shouldn't be 0. So derivative of x according to t shouldn't be 0. What it means, when we have derivative of x, when we have derivative of x according to t 0, let us see derivative of x and derivative of t. Okay, if we have this 0, what this means? This means that derivative x equals to, okay, just a constant number. Okay, let us say 2. So derivative of a constant number is 0. So it shouldn't be a constant number. Okay, it means this. It shouldn't be a constant number. So you know that all these terms here, in fact, should be like x is a function in terms of t. Okay, we are talking x being a function in terms of t. Okay, here the derivative, you know, is 2. Okay, and derivatives becoming 0 is that x being a constant. So in other words, here in this equation here, x cannot be a constant. It cannot be 2, 3, 4, 500. Okay, because derivative of that numbers are 0. Okay, so let us continue with these definitions here. Here, let us say second derivative of y according to x. Okay, this means second derivative of y according to x. Okay, So here, look here what we are doing. Here we are taking, first of all, this is first derivative of y according to x. This is first derivative of y according to x. And we take one more derivative of it. So it becomes second derivative, okay? First of all, what you do, you take derivative of y according to x, and we take one more, it becomes second derivative. Okay, good. Now here, what it says? Here it says that, okay, so here this is derivative of y according to x, okay? So here, if you reverse this one, you will see that it will be dt over dx. And it will be just same thing as this one. I will try to copy it to this place. File, new, okay. It doesn't allow me to copy it. Okay, so again, I need to write it a little bit to explain. So I take this part here, and maybe I make it smaller. Take it to the other side. Yes, here. Okay. So in this part, what we have, I'm talking about this part here. It is important to understand this part. That's why that I will draw it to here. So here, what we have, I start from this part. Okay, this is derivative of this is derivative according to x. Okay, so here what I have. This is derivative of y according to x, derivative of y according to x, derivative of x. Okay, so this means second derivative of y. How we were referring it? We were referring it like this also. Remember, we were referring like y to dash. This is also second derivative of x. We have different representations of them. So here also, d to the power 2, we can say d to the power 2, okay? Y is here, and we have it like this, over the dx, what I did, I went from here, dx to the power 2, okay? So, be careful of the representation. When we are representing second derivative, this is the way that we do it, okay? We have 2 here at the top of d, and we have 2 here, okay? This is just a representation, this is just a symbol of second derivative, it is nothing else. We don't put 2 here, okay, as a, here at the top of d. We put it here. It's just representation. It has nothing important, but you cannot do it other ways. You cannot do it like this, for example. You cannot write like this to represent second derivative. This is not possible. This is not the way, okay? There's a way of doing it, and the way is just that. You put 2 here, okay? And this doesn't mean that power of 2 or anything. This doesn't mean that power of second power of x or x squared. It doesn't mean anything about that, okay? This doesn't mean that it is x squared. It is just the representation, but we cannot write it like this. This is not true. This is meaningless in calculus, okay? This is meaningless. We have symbols, we have rules, you know, math consists of lots of rules. And here, there are representations also. There are some symbols, there are representations, and to represent second derivative, we have 2 here, d to the power 2, okay? This is not in fact power, this is just representation, d at the top 2, and we have nothing here, and we don't have 2 here. We write 2 at the top of x, but it's not power, it's not x squared, okay? This is just representation. It may be confusing, that's why that I am repeating it to make you understand it truly, in the true way. So, most of my students mix this is not x squared, I'm repeating, this is just the representation of second derivative. We represent it like that. This is the rule. Okay, so here, now let us see what's happening here. It says d over dt is taking derivative according to t. Okay, this is taking derivative according to t. So I have to use this symbol over here. Okay, d over dt. Okay, good. So d over dt is means taking derivative according to t, and I'm going to have the brackets like that. So it says dy over dx. Okay, let me write also dy over dx, dy over dx. Okay, good. So here, what this means here? This means take derivative according to x, okay, and then take derivative according to t. This means it. Okay, so let us reverse this side here. Okay, this says dx over dt. Okay, in the denominator we have dx over dt. So let us reverse it. I write multiply by. So I write multiply by and I write dt over dx. You can see it at here. This is dx over dt. I write it dt over dx. So watch it here. What I have, you see, I have one at top and I have one at down. Okay, I cannot cancel them. Okay, these are representations. These have different meanings, as I say here. This even doesn't mean a power. Okay, so you cannot cancel it, but in your imagination, it helps you to think, to find how to do, how to solve these questions. See it, one is here, the other one is here. You don't do the cancellation, but it works like that. Here you see that it's dy over dx, and this in fact is equal to, okay, this in fact is equal to this one. This here, dy over dx, okay, multiply by, or multiply 1 over dx. This is taking one more derivative, in fact, 1 over dx. Okay, we don't do a cancellation. Please be careful. Don't put this cancelling signs to me. It's not cancellation, okay? But the result equals to this one, okay? Imagine it. You can think in your mind that you omit them, okay? You see that this is dx here. This is this is dt here, and this is dt here. You can omit this one. And what I have here is that this is dy over dx, and the rest here is that I have, okay, I can write, of course, the d there. This is d over dx. Yes, I left d over dx. But this means again, all this means again, just the same thing as second derivative of y. This is the same symbol as this, as the one here at the top here, all the stuff we have here. Okay, this is the same thing. This is just a representation and symbols, and I suggest that you write this on your math notebooks and get used to writing them, because they are not easy. They may be confusing, okay? But once you understand it, it will be easy. Okay, so I will continue from here, what I have. So it says, okay, there is a equation here, and we have a curve, okay, C is defined by the parametric equation. So there are two functions here, okay? I have x in terms of t. This is t square, okay? This is really square. Okay, when we talk about derivatives like this here, okay, this is not square, but here this is square. Okay, and I have y here, and it is a function in terms of t. Okay, so here in fact I can write this y. I can write this as yt. Okay, this is the same. This is a function in terms of t, but in maths, you know, there are many representations, and sometimes we omit some representations there. This is t to the power 3 minus 3t. 3t, okay. So this is y in terms of t, okay. But as you see there, sometimes we omit it, okay. We omit it, we don't write it, but this doesn't mean that this doesn't equal to this, okay. So these are just same. This is a function y in terms of t, okay, good. Now let us continue. There is a function x in terms of t. Also this is a function x in terms of t. This is the same representation. You can write it like that. Equals to x here, and this is t to the power 2. This is t to the power 2. Good. So question A, what it says? It says show that C has two tangents, okay, at the point 3, 0. What is this 3, 3 and what is this 0? This is x and this is y in fact, you know. And find their equations. So it wants us to find the tangents. So to find the tangent, it's the slope in fact, and slope, you know, the derivative, okay. Whenever equation wants us to find tangent or slope, we will find derivative, and we will have other equations after break. Then you are going to use integrals. So to find slope or tangent, we are using derivatives. To find areas, we are using integrals. Okay, so let us continue with the solution here. Okay, what we are going to do. Recall here the equation consists of, this is the y. It is a function in terms of t to the power 3 minus 3t. Okay, here it's 3 to the power 3 minus 3t. Excuse me. Yes. Here it's t to the power 3 minus 3t. And here you can take it to the common brackets. You can write t here, and it's t square minus 3 equals to 0. So this is just having common brackets. Okay, so we are going to find the roots of it. Why we are doing it? Because we want to find the roots. We want to find when y equals to 0, what is the, at what point it cuts the x-axis. Okay, so here it says t equals to 0, and this is t equals to plus and minus square root of 3. You know, when you solve this, t square minus 3, you get this solution here. Okay, so here it says at the point 3, 0. Okay, on C it comes to these values. So yes, here these are the points where this y equals to 0. You see this this is x and this is y equals to 0. So here what we do, we put this y equals to 0. So this 0 comes from here. Okay, so what did the equation wanted from us? The equation wanted us to find a tangent that it passed from 3, 0. So we find the point that it cuts when y equals to 0. Okay, this is the point that it cuts its x-axis. Okay, when y is 0, it cuts x-axis, so it cuts from these 2 points. So here, what else we have? In this equation, we are going to find derivative of y according to x, okay, here. And you see that for doing that, we have to use this rule here that we have explained. We are going to find derivative of y according to t and derivative of x according to t. Recall that the equation gives you two functions. This is a function. This function is about x-axis. So I can write it like this. Okay, x-axis. okay, and this is y-axis, okay. So this is this is y-axis, okay. So so what we do here, first of all, we put y equals to 0. That's what equation says us, okay. And in this equation, and we find values of t. Then here, okay, come to here, okay. So, but we want to find derivative of y according to x, okay? Why? Because this is the slope, okay? So, to find the slope, okay, we have to find always derivative of, to find the slope of this curve, okay? We have to find always derivative of y according to x. So, this is the slope. Not there, and this right here. Okay. So we have to find this dy over dx, okay? This is the slope. So for this slope, we y is written as a function, okay? This y is written as a function t here, and x is a function of t. So we have to deal with this first, and then we have to find this. For finding this, okay, for finding the derivative of y according to x, we have to apply the product rule, okay? We have to apply this rule here. We have to find derivative of y according to t first of all. This is derivative of y according to derivative of t, okay? And then we have to divide it with, we have to divide this one. We have to divide this one here, okay? We have to divide this one as derivative weight. We have to divide this one with, this is derivative of x over derivative of t, okay? We have to divide it by t. So what we have here, we have, you see that we have here, this is derivative of y over derivative of t multiply. You see that this here, we reverse it, okay? We this is dt over dx. So when we turn it to multiplication, it becomes this is dt over dx. So now okay, we don't this is dy, wait, this one again, this is dy over dx, or I can write it as these are same representations, okay? So this is derivative of y according to x. I can either write it, or in fact here y consists of t, okay? Here it's a function of t, x is a function of t, and in order to find derivative of y according to x, because curve of slope of a curve is always if it consists of y and x values. You know, the coordinate axis consists of y and x, and there the slope is derivative of y according to derivative of x. So in order to find the slope, we have to find the first derivative, the derivative of y according to x. But here the y was in terms of t, x was in terms of t, so we have to do the product rule to reach to our conclusion. And the slope is the tangent line here. Okay, so let us continue. So here, yes, this one, okay? You see here, this is derivative of y according to derivative of t. Let us see what was this derivative of y. So what is it? 3t square minus 3. 3t square minus 3. Here you can see it. Over this 2t here. Let me take some shapes for representation. For showing. Just okay. So here, okay. So you see that this is 2t. It is a derivative of x over derivative of t. Why? Because look here, this is t square. T square is 2t. Okay, t square is 2t. So this here, it moved. Okay, it is equal to this one, and when you simplify it, you get this result here. So how you simplify it? We take just common brackets of 3 over 2, and we see that this is t over 3 over, so 3 over 2 was here, so it is 1 over t. Okay, so here we get this result. So we found before that we wanted to find, the equation asked us the slope of the tangent line at this point, okay? So it says at this point. Therefore, we put 0 instead of y, and we solve for t, and we find these values here. Where did we find them? We find them here, okay? When we put, because it says at this point, so we put y equals to 0, and we find these values here, 2 values of t. And where are we? Not here. Wait, yes, we were here. Okay, so it says, okay, we want slope at this point, okay? This comes from the equation said as at 3, 0. And at that value, this equation here equals to, when we set this here 0, we get this. And so in order to find, this is the slope, okay? So at this point means, let us substitute t instead of this here, okay? Let us substitute t here. So you put t in this equation here, and you get this result. So what we are saying, the equations of the tangents at these points are these ones. So how this come? This come, okay, we find this here. This is a slope, this is m, okay? And we can write y equals to mx plus c, and we can find these equations here. Okay, so yes, concativity. In order to find whether it is concative or not, and whether it is concative, it goes upwards and downwards. Let us solve this second derivative. We can if we calculate the second derivative, we come to this here, this equation. So we see that it is not definite when t equals to 0. It's not defined. Evet, yes, Ferhat. Bir şey mi soracaksınız? Bakalım. Okay, so here, it's not definite, okay? It's not defined when t equals to 0. T equals to 0, it's not defined. Okay, but we can have this, okay, this value here when t bigger than 0, okay? This result will be positive. When it is smaller than 0, the result will be negative, okay? And you see that the t square is always positive here, and here if it is a negative number, okay, it is negative, the result is negative. So if it is negative, it concave downward, okay, and it is positive, it concave upward, but it's not defined when t equals to 0. Yes, okay. So this is the sketch. Let us see the sketch here. I'm going to make this bigger and even bigger. Slideshow from current slide. Yes. Let us see. No. Okay, here. So let us see this question. Sorry. I'm clicking to much places. Yes. So now I'm searching my laser. Here's my laser. Okay, it didn't come for now. Yes, here, let us look what we have here. Okay, this is 30, okay? This is 30, point 30. So this is our curve. Look at the curve. It goes from here to here. So this is our function, okay? This is our curve. This is our curve. It comes from here. It cuts the x-axis, okay? You see that it's 30. This is the point. It cuts the x-axis, okay? And it comes here. It goes like this. And now this is the tangent line. You see that there's one tangent line from here and there's one tangent line from here. That's why that we have two answers. The question asks us to find the tangent lines. You see that this is the slope, this is the tangent line, okay? Equation of the tangent line. So here there are two tangent lines because our curve comes like this. Watch the arrows. It comes from here. It goes and it goes back. Okay. So we have two tangent lines here. This is the first tangent line and this is the second tangent line. Therefore, we have two results. Like we have two results. Where are the two results? Yes, like this. Okay. So this is the two results. Okay. And we have two equations because it cuts that point 30 and there are two tangent lines, not one tangent line. Yes.